Okay, question 5M3 from Statistical Rethinking, second edition. Make sure if you're going to run this code that you have installed and loaded the rethinking package with these two blocks here. And let's get into it. Okay. So this question, I guess you can read the question, but it's asking us to consider reverse causation. Okay, and so it gives a couple of examples here, and one we're supposed to discuss. But the first one is first observing that that fire risk can be predicted by the number of firefighters in the area. And so now, of course, this does not mean that firefighters are causing fire, but rather that fire is a cause for the presence of firefighters. Okay. So this asks us to consider the possibility. So just as that would be reverse causation, right? This asks us to consider the possibility that between divorce and marriage rates, that divorce rate is causing a higher marriage rate. Okay. And can we think of a way to evaluate this type of a relationship? So earlier in the chapter, there was discussion of the divorce data set. I can't remember the exact name of the data set, but one of the things that was posited there is that marriage rate is somehow a cause of divorce rate. And so now we're looking at the opposite scenario and trying to see, first, can we think of a way in which the opposite scenario might be true, and then how might we test it? So, So let's go along with that. So I have a little bit of a more detailed answer here, but divorce rate, I guess, could be a cause of marriage rate, or in one of two scenarios. One is that it depends on how we define rate, okay? So, or marriage rate and divorce rate. So if marriage rate and divorce rate was the number of marriages or divorces taking place during a certain period of time, that would be one way to define it. But the other way I think that it could be defined is the number of people that are currently married or currently divorced. And that would be a different definition. So in the second definition, where we're just the number of people in either marriage or divorce, divorce is a cause of marriage, but it can only decrease marriage. And this relationship is true really by definition, I guess. If people are divorced, or, you know, as long as they're not remarried, then they're not married. But it could be that a higher divorce rate increases the pool. So if we go back to the first definition, if a higher divorce rate means that we're increasing the pool of people that could get married, as long as the divorce doesn't dissuade people from wanting to get remarried, then divorce could be a cause of a higher marriage rate. So anyway, so we could model marriage rate as a function of divorce rate, if divorce rate was somehow a cause of it, with some kind of regression like this, right? The rate of marriage is, oh, I forgot a beta coefficient in there. Let me pause that and fix this real quick. Okay, so marriage rate could be a function of divorce rate plus, and I put an epsilon in here, or an E, and that just represents other things that are causing marriage rate that we're not accounting for or don't observe, or something like that. So so this type of a regression would imply a DAG like this. Divorce is causing marriage, and these other factors are also causing the marriage rate. Okay. Now, if for whatever reason that seems like a suitable model, then great. But probably the relationship between divorce and marriage is a little bit more complicated than that, right? So, for instance, by the same relationship wherein divorce rate increases the number of people that can get married, and so the marriage rate goes up, the marriage rate increases the number of people that can become divorced, and so we would also expect marriage to be causing divorce. And in this case, we should have another arrow going back that way. Okay. Well, now all of a sudden we do not have a DAG. Remember, the A in DAG stands for acyclic. And the acyclic part means that there's no cycles being formed amongst these arrows. But as soon as we have another arrow going from M to D, we've created a cycle, okay? In the Daggity package, it might look like this with this two-headed arrow. I don't know if there's a way to have a separate arrow going in both directions, but our DAG might look like this. And for reasons that we won't really get into depth here, these kind of two-way relationships are not well handled with just simple regression. I want to take a moment here and just refer you to a couple of good resources. First is there's a good discussion on reverse causality with by Ben Lambert. It's an old playlist, but it's excellent. And so here's links to part 1 and part 2. And so here's the page, and we won't go into it, but you should definitely watch this if you're interested in reverse causation here. And just along those lines, I also want to just recommend Ben Lambert's book, which, in addition to Statistical Rethinking, is a fantastic way to begin learning Bayesian stats. And so there's a link here to the Amazon page where you can purchase it. Yeah, it's a great book. And his book is also, just like the Statistical Rethinking, is also accompanied by a lecture series, and these lectures are also fantastic. The Lambert book goes into a little bit more nitty-gritty detail than Statistical Rethinking, but it's very good. Okay, anyway, so this kind of back and forth relationship between divorce and marriage would probably need to be handled by something like a time series analysis, and we're not going to go into time series analysis, but if we want to make a DAG for it, the DAG would look like this. So a time series looks at divorce rate and marriage rate at discrete time points, at consecutive time points. So along the top here we have divorce at time point 1, divorce at time point 2, divorce at time point 3, and then along the bottom we have marriage at time point 1, 2, and 3. And so what we see is that divorce rate at time point 1 is a cause of divorce at time, or of marriage at time point 2, and marriage at time point 1 is a cause of divorce at time point 2, and so on and so forth. And so this kind of back and forth pattern could just continue indefinitely. And also, just to note, I notice I've dropped the E term here. It would be in there, but just for clarity, I omitted it. Okay, that's it for this one. Thanks.